What is the equation of the line in slope-intercept form that passes through the point negative 2, 5 and is parallel to 3x plus 2y equals negative 2? Well, we know that we are given a point right here. And anytime we're trying to write the equation of a line, we generally are going to label this point x1, y1. I know I want a line that is parallel to the given line. Well, parallel means I need a slope that is the same. So we've got to figure out what our parallel slope is going to be. But in order to do that, I have to take this equation and I need to put it in slope-intercept form. Okay, remember, slope-intercept form is y equals mx plus b. That's what I need my equation to look like. So let's take 3x plus 2y equals negative 2. And we need to isolate our y variable, right? We need to get our y variable by itself. So I'll draw my line to separate my equation. And let's manipulate this. We need to isolate the 2y term first, so let's get rid of our 3x. We'll subtract 3x from both sides of our equation. And 3x minus 3x, of course, is 0. So we'll drop down our 2y equals, and I cannot combine these two factors because they are not like terms. So I'm going to go ahead and write the minus 3x first, because remember, I'm trying to make it look like this equation up here, and my x variable is first, or my x term, and then we have minus 2. Okay, so I've got 2y equals 3x minus 2. Let me scoot this over just a smidge. There we go. All right, so I still need to get the y by itself, so let's divide by 2, which means I need to divide every term by 2. And what does that end up giving us? Well, 2 divided by 2 is 1, so we've got 1y, or just y, equals negative 3x over 2. That's not going to simplify. Negative 3 divided by 2 doesn't reduce any further. We have an x value, and the negative 2 divided by 2 gives us our minus 1 right here. All right, now that we're in slope-intercept form, remember our slope is always attached to the x variable. So our slope in this problem is negative 3 over 2. And because I want a parallel line, I am going to use the slope of negative 3 over 2. So let's fill that in, negative 3 over 2. So this is the information that I'm working with. I have a point and I have a slope. If you're given a point and a slope, what formula do we use? We're going to use point-slope form, which is just y minus y1 equals our slope times x minus x1. Okay, so in order to simplify this or to write this equation, we just need to sub in our values. We have y minus, our y1 term is the number 5, should equal our slope, which is a negative 3/2, times x minus our x1 value, which is a negative 2. So if I substitute in a negative 2, minus a negative 2 really turns into a plus 2. Close our parentheses. So this equation right here is perfectly acceptable. It's absolutely 100% correct. But the original question asked us to put this equation in slope-intercept form. So we need to get rid of our parentheses and we need to isolate our y variable. So let's go ahead and draw our line again to separate our equation. And in order to get rid of our parentheses, we just need to distribute first. So negative 3/2 times x gives us a negative 3/2 x. Negative 3/2 times a positive 2 gives us a minus 3. Okay, we have our equal sign, and then we bring down our y minus 5. We didn't do anything with that. And in order to get our y variable by itself, we need to do the inverse or the opposite of minus 5, which is plus 5. So when we add 5 to both sides of our equation, what does that give us? We have y equals negative 3 over 2x. Minus 3 plus 5 gives us a plus 2. And this is the equation of our line in slope-intercept form that contains the point negative 2, 5 and is parallel to this equation right here. Okay? So that is how you can write the equation given this information. Very quick reminder, if you look at your notes, problem number 6, it asks the same question, but in this problem, it is asking for a perpendicular slope. It's asking for a perpendicular slope. So let's go through that really quickly, just how to find the perpendicular slope. So again, I need my equation in y equals mx plus b form, my slope-intercept form. So in order to get this y variable by itself, we need to subtract 3x from both sides of our equation. And that ends up giving us negative y equals negative 3x minus 3. Remember, we can't combine these two terms because they are not like terms. One has a variable and one does not. It's just a constant. But now I've got this negative y on the left side of my equation. And we've got this invisible 1 right here. It's a negative 1y. Okay, so the opposite of that, or the inverse of negative 1 times y, is we need to divide by negative 1, which means I need to divide every term by negative 1 to keep it balanced. All right, so negative 1 divided by negative 1 gives us a positive 1y, which would equal negative 3x divided by negative 1 gives us a positive 3x. Negative 3 divided by negative 1 gives us a positive 3 again. All right, so here we go. Remember that our slope is always attached to our x variable, so we have a slope of positive 3. But remember, we need a perpendicular slope. So our perpendicular slope for this equation is the opposite reciprocal of positive 3. Well, opposite means I change the sign, so I know it's going to be a negative number. And then the number 3 can be written as a fraction, 3 over positive 1. The reciprocal of 3 over 1 is just 1 over 3. All right, don't forget, when you're talking about perpendicular slopes, you change the sign, you flip the fraction. So the perpendicular slope that we would use for this problem is a negative 1/3. Now you can go on and finish writing your equation.